Okay, so we're going to do lesson 2 on multiplying integers, and I know we've covered this already, but a lot of people missed class, so we're going to go through some stuff again, and I'm going to give you guys some different homework to do so you can practice this skill over. And while we go through it, I'm also going to talk about the visual ways that you can show integers being multiplied. So I'm going to move this over here. So multiplication is the same as repeated addition. Therefore, let's put that there. Therefore, 5 times 4 is really the same as saying 5 plus 5 plus 5 plus 5. So if this is true for whole numbers, then it's definitely true for integers as well. And by the way, just as we're going through these notes, you should be filling in the blanks in your notes booklet that you started just the other day. You should be filling those notes in, and that's going to help you to retain the information. Okay, so this is an example. If you owe your mom $2, you owe your dad $2, you also owe your sister $2, your friendly banker $2. What is the repeated addition that we could do to represent this? And I want you to draw a picture to represent this. So you're owing each person $2. So it's 2 plus 2 plus 2 plus 2 plus 2. Yeah. So you need to make sure that you're able to do that. And 2 plus 2 plus 2 plus 2 is the same as 4 times 2. Or another one. The temperature falls 3 degrees for 6 hours. Use number line to find the total change in temperature. So we can use, this is you could look at it like a repeated subtraction problem or repeated addition problem, or you could look at it like a multiplication problem. But you can use a number line, which is a visual way of showing that. So if it falls 3 degrees for 6 hours, and you need to find the total change in temperature, your total change should have been 18 degrees. Or if George deposits 3 sets of $10 bills into the bank, write an equation to show the money in his new account. So, it's $10 plus $10 plus $10. 10 plus 10 plus 10 is 30. So you're showing that repeated addition is the same as multiplication. So if you take out 6 sets of $5 bills from your account, then what would the equation be? It would be 5 plus 5 plus 5 plus 5 plus 5 plus 5, or 6 times 5. So there's different, and if it's an equation, you're going to say that 6 times 5 is 30. So I want you to understand that repeated addition is the same as multiplication. So there's some rules we can apply when we're multiplying integers. One rule that we can apply is the zero property. Anything multiplied by 0, whether it's an integer or a whole number, equals 0. So 3 times 0 is 0, 0 times 3 is 0, negative 3 times 0 is 0, 0 times negative 3 is also 0. Another property that we can rely on is the commutative property. If 3 times 4 is 12, and 4 times 3 is 12, then negative 3 times 4 is negative 12, and 4 times negative 3 is negative 12. And the last thing that we can rely on as well is the commutative property, and that's, the multiplicative identity. Anything multiplied by 1 equals the factor other than 1. This is because multiplying a number by 1 does not change the identity of the number. If 3 times 1 equals 1 and 1 times 3 equals 3, then negative 3 times 1 equals negative 3, and 1 times negative 3 equals negative 3. We can also rely on the distributive property. 3 times 4 plus 5 equals 12 plus 15. If this is true, then 3 times negative 4 plus negative 5 equals negative 12 plus negative 15, which equals negative 27. So as you can see, there's laws and there's rules in place that make this math make sense, and it's not like we're using a totally different number system when we're multiplying and dividing integers. It's very similar. So we've been through these rules before, but you need to memorize these rules. Therefore, anytime that there is a mix of a negative and a positive in a number sentence, the product is always negative. And this is when we're talking about multiplication. This is not the same for addition and subtraction. A number could become more negative or become more positive, but if you add a negative and a positive, it does not become a negative number. In other words, the negative is dominant in multiplication. Anytime that there is the same sign with a number sentence, the product is always positive. In other words, the positive is dominant. So if there's two negative signs, then that's going to become negative. If there's two positive signs, then the positive is dominant. Okay, so that's going to wrap up. You don't need to do this. This is not for you guys.